Hello, I am Yunseong Kim. As a Linux kernel contributor in my hobby, I'm working in some security thing in my office. I'd like to share my experiences and lessons learned from the kernel vulnerability reporting process and Linux kernel fuzzing. I will explain what it means for the Linux kernel to become a CNA and what I have experienced after CNA. Also, I will introduce the syzkaller, a kernel fuzzing tool that has been extremely helpful in finding Linux kernel vulnerabilities. Now, shall we talk about Linux kernel CNA and CVE? The Linux kernel project became a CVE numbering authority, CNA, in this year. Now, Linux kernel CVE team can directly assign CVE numbers. CVEs are assigned only after patches are released. Linux kernel CVE team has been assigning CVE to bug fixes with careful review. A vulnerability tracking is managed through a dedicated Git repository. This works ensuring more transparent security information for all Linux users. This is the repository address. Now, this is the kernel.org repository that manages kernel vulnerabilities, which I just explained in the previous slide. For those interested in Linux kernel development, we can see the names of notable Linux kernel maintainers, Greg and Shashel Revine, and their collaborative works in here. Looking at these command logs, you can see the review process for the applied potential security patches. Isn't it really active? While observing the Linux kernel CVE team's work, I noticed they follow this main process. Propose, done, CVE announcement. The CVE team's documented process shows how vulnerability patches are reviewed and tracked for each kernel version. Patches are organized into two sections, proposed patch under the review and complete patches in the done directory. Once CVE team completes their review, they publish the patch and its assigned CVE numbers to the mailing list. The Linux kernel CVE announcements are published on the following mailing list address, role.kernel.org/Linux-CVE-announce. The right image shows the mailing list filtered for S390 architecture. You can see the two CVEs I discovered. I will explain this in more detail later slide. This is some subscribing mailing list address. Let's explore how to find and report Linux kernel vulnerabilities through the official Linux kernel security channels. The kernel security documentation explains the reporting process with this highlighted word. It follows standard patch submission, but needs comprehensive details about the vulnerabilities. I've learned a lot from two excellent resources created by respected kernel security researchers, ZRE and Google security team, that offers valuable guidance of this process. I will share my journey of reporting my CVE, first and second kernel security bug, including the challenges I faced while using a kernel fuzzer. Actually, Linux kernel security more related to user privilege in the context, not the privilege context in the control plane bug, more user plane bug. This is first CVE I've received this year related to user-first FD with user-first FD poison. When we utilizing this feature, we can crash the IBM G Linux system, former mitigated version with user privileges. This is my security report. I included as much detail as possible in my analysis. But then, Linus replied, correcting my misunderstanding and providing a more general explanation. In fact, this is first email I've received from Linus. Cheers. Linus referred to syzkaller as a reproducer, which we can discuss further in the syzkaller chapter. He also shared a patch that prevents this crash issue. Linus encouraged the involvement of people who are maintaining the subsystem X390 architecture. And then IBM maintainer Gerald replied with a detailed analysis with mitigation patch. He added some branch code. So I tested it with the same scenario, and Gerald's patch successfully prevented this kernel crash. I also asked questions about what I didn't understand. Gerald provided more detailed explanations and directly questioned to Linus and Greg as part of the normal bug fix process. Then, Greg mentioned that this normal bug will receive a CVE. Cheers. So, this is the CVE announcement for this issue. The patch was applied, but there was a gap of 2 weeks before the announcement. This delay allowed for the backporting to various distributions. This is another CVE that I discovered. This is also a crash issue that a normal user can trigger in the IBM G S390 architecture. The kernel code has trouble with an assumption that is not possible, but certain kernel options can break this assumption. This is the core stack, and there was a missing check for the memory page flag in the IBM G architecture's memory management subsystem. Linus also replied regarding this patch. He described it as a regular bug, which refers to a programmatic oversight. This is not a difficult bug that requires refactoring a subsystem. So the IBM S390 maintainer fixed this code with a detailed patch message. Thank you, Heiko. So I tested it again with mitigation patch applied, and this patch successfully prevents the crash I discovered. Finally, the CVE has been announced. Cheers. I will introduce the Linux Kernel Fuzzer. Let's get started. What is Kernel Fuzzer? The Linux kernel uses system calls to connect user and kernel space and handle device communication through network and hardware protocols. KCOV provides code coverage information for fuzzing for each system call or collecting remote coverage information from kernel thread or soft IRQ context. This feature maximizes testing effectiveness. Linux kernel debugging features provide powerful tools for fuzzing operation, offering detailed bug detection with analyzable core stacks. Additionally, kernel sanitizer evaluates compiler features to detect runtime memory bugs and race conditions. What is syzkaller? This is an automated system continuously tests the kernel while managing an efficient collection of the test case from maximum code coverage. You can refer to the link provided later for hands-on practice. This tool have a key point interface-based test generation, smart corpus management, comprehensive crash analysis. This is bird's-eye view of how syzkaller operates. When Sys Manager is executed on the management machine, it runs fuzzing process on the target machine. The fuzzing management system collects and manages all the information generated during the fuzzing process. So this is the management process from management machine, and this is the target fuzzing process. This is configuration files is read by Sys Manager to control and manage guest target machine. This target machine are QEMU virtual machine. ARM64 Linux runs 3 fuzzing processes, specifically test SMB file system code by filtering coverage to fs/smb files and ksmbd functions. Restrict fuzzing to only to syscall. Here's one syscall, right? Enable code coverage tracking for better fuzzing efficiency. Uses a single fuzzing target VM instance with 4 CPU cores and 4 GB memory, enable KVM acceleration, and use host CPU model. This run in my Raspberry Pi 5 in my home. We can fuzzing target with user mode with these options. Here is the option about privilege and SenUI mode running as user nobody. Namespace mode requiring config on the user and S in kernel configuration. Kernel fuzzing helps company comply with CRA requirements while avoiding penalty and reputation risk. As you know, CRA has some penalty fee. This is big deal, right? So this contribute the company's product stabilities. Setting the sandbox to none allows operation with root privileges. This helps find many bugs suitable for kernel contribution. Bug fixing is meaningful work in itself as an open source contribution, right? And it's essential for becoming a Linux plumber. It is important to thoroughly check the mailing list for any existing related patch in the specific subsystem tree before proceeding. Kernel fuzzing using syzkaller can be performed on isolated embedded system with specific hardware configuration with pstore. How is Google using it? Let's see Google's usage of syzkaller through their syzbot dashboard and syzkaller mailing list, which show how they manage kernel testing and bug reporting. This is the address of syzbot upstream dashboard, and this is the mailing list. Some of development next branch, Linux stable, BPF, and some Google-related branch. And this is an open issue. So many bugs in here, right? We can see there are many kernels on this dashboard, such as x86, RISC-V, ARM 64 with Google Computer Engine configuration. Oh, there are so many new bugs, right? This is now and just a minute, right? So how can we fuzz it? These are the architectures I've worked with, but there are still many architectures I haven't explored yet. So I checked this sanitizer option can enable in this architecture. So we need to build some kernel with debugging configuration, and we need to some virtual machine QEMU, KVM enabled or host CPU preferred because fast, and prepare root file system. I tested Yocto framework and also some Ubuntu or Fedora image with initrd. And we need some sh key file. So Google tested it with configuration. So this is the first debug configuration. We need debug configuration, right? So there's some debug configuration in Fedora and the syzbot dashboard with that config. This is the dashboard of syzkaller. We can find corpus, coverage, supported syscalls, and crash. This is reproduced bug. SMP process ID in printable code in event function call. This is patched last Linux kernel version. So this is some generated reproducible bug. This is a kernel log from this page log. Report. This kernel bug that crash occurred, we can see the perf event. This is the syzkaller log from each corpus made. Syzkaller makes some mutate some input. This is each system call, and syzkaller makes some arbitrary input for this system call. How can we reproduce it? We can reproduce in the target machine with sysexecprobe and scenario log made from the corpus with this previous slide. Additionally, we can make C-source code from the previous syzlang log, filtering, testing to focus on specific system core or devices file. This is some tips when we learning syzkaller. Tmux, using Tmux for session liveness, and we prefer some fast option in QEMU, and this is some tip, sufficient disk size, etc. We can find information with syzkaller source code, some filtering on the configuration file, make effective fuzzing the Linux kernel. PCS fetch file, raw PC table file's name, each line of the file should be this format. We can have the syzkaller to make more fuzzing other kernel program or brand new kernel module. This is important. Syzkaller needs some syzkaller descriptions and pseudo system call. So I made it for the fuzzing the KSMBD subsystem. So syz, KSMBD, send the rec, and syzkaller will mutate this input in here. and this pseudo system call that input the mutated argument from the syzkaller. This is the C code that mapping with this. And I added a pseudo system call in linuxsyscall.go file in syzkaller. Let's review what I said first time. Do you a little bit more clear about security reporting in this session? If you didn't talk with me in other channel, and let's discuss more on this. I prepared some my mistakes. I encountered during my first attempt at security bug reporting, this patch has several problems. When we reproducible this bug, we need root privileges. This is some app-trace-related bug. According to Greg's feedback, there are several issues with this security report. Security mail and CVE report should not be combined. The patch needs a fixed tag. The reported bugs require root privileges and are control plane issues that don't directly impact the system security. And other try and error. I reported this bug through the following patches. The issue involves a double-free memory bug caused by a synchronization problem. According to Greg's feedback, security and CVE mailings should be kept separate. So security-kernel.org is a private mail that's not publicly opened. Additionally, the following cases are unlikely to be considered security vulnerabilities. Patches still in progress in Bluetooth 3, not in Linux Next. Bugs requiring complex conditions that are difficult for regular users to reproduce. Control plane bugs requiring elevated privileges like root access that don't directly impact system security. Fixing kernel warning is good, but I recommended looking at the broader context of the subsystem. Simply focusing on the specific code for the security purpose without considering the context can be short-sighted. This is the summary in my session. Thanks again for joining my session. Thank you.